In this lecture, we'll be studying about threats. Threats are an important topic in operating systems, and in one of the previous lectures, when we discuss about process management, I have shown you the difference between processes and threats. So I told you that a program under execution is known as a process, and threat is a basic unit of execution. So each program may have a number of processes associated with it, and each process can have a number of threats executing in it. So thread is a basic unit of execution, or a basic unit of CPU utilization. So that is how we can define a threat. It is a basic unit of CPU utilization. Now let us see what comprises of a thread. So a thread comprises of a thread ID, a program counter, a register set, and a stack. So each thread comprises of these four unique items. And apart from this, it shares with other threads belonging to the same process its code section, data section, and other operating system resources, such as open files and signals. So these are the things that comprises of a thread. And apart from that, the thread shares these things like the court section, data section, and other operating system resources are shared between threads belonging to the same process. So as I told you, a process can contain different threads. So the threads belonging to the same process will share the resources like open files, signals court section, data section, and other things. So that is how a thread is basically made up. So a traditional or heavyweight process has a single thread of control. But if a process has multiple threads of control, it can perform more than one task at a time. So a traditional process, also known as a heavyweight process, had only a single thread of control. That means it can have only one thread. But this is not a very efficient system. But if a process is having more than one thread, then each thread will be assigned a different task. And hence that process can perform more than one task at a time because it is having multiple threads, and multiple threads will be performing multiple actions. So there we see how threads becomes useful, and how using threads makes the system much more efficient. So here let us try to understand the concept of threads using these two diagrams. So here in the first diagram, it is a single-threaded process, which we refer to as a traditional or a heavyweight process over here. So here we are having only a single thread. So this whole block is considered as a process, and this process contains only one thread. And this is the code section, the data section, the files, the registers, and the stack belonging to this process. So there is only one thread. That means this process can perform only one task at a time. But in contrast to this, here we have another diagram showing a multi-threaded process. So here this whole block represents a multi-threaded process. So it is a single process, and it is having multiple threads over here. So if you see, there are 3 threads in this process, and each of these threads, they have their own stack and registers. So all these 3 they have their own stack and registers. And if you see on top, the court section, the data section, and the files belonging to this process are shared by these 3 threads. And each thread, they have their own stacks and registers. So this is a diagram of a multi-threaded process. So in this case, this process can perform multiple tasks at a time because each thread will performing a different task, and hence multiple tasks can be performed at a time by the help of this multi-threaded process. So from that itself, we must have understood that it is much more efficient as compared to the single-threaded process, and it will make our computation faster and more efficient. So in most of the systems that we use today, we follow the system of multi-threaded processes. It will be good if we can visually see how it works in our system in order to understand how processes are there and how threats are associated with the process. So here I have a small software called Process Threats View, which helps us to see the processes and the threats running in our system. So if I click here, I can see the processes running in my system. So I have opened the Chromium browser in my system. So here I can see the Chrome.exe processes which are running in my system. So there are quite a few number of Chrome.exe processes running in the system. Now if I want to see the thread associated with it, I will just click on it. And here the details about the thread is populated, so there are this many number of threads associated with that single Chrome.exe process that was running. So as I told you, the thread comprises of a thread ID. So these are the IDs of the thread, which identifies those threads uniquely. And then these are the context switches, and the last context switches that happen. So we have discussed about context switches in one of the previous lectures. And here there are so many informations about the thread that we have selected. Now if we come here, we can see that there is the address of the thread, and here we can see the details of the stack associated with that process. So I told you that threads also contain a stack. So in this way, we can see what are the processes running in our system, and we can also see the threats associated with those processes. So we clearly see that in this system, it is following a multi-threaded approach. So when I click that single process of the Chrome.exe, we see that this many number of threads are running inside that process. So each of this stretch may be useful performing a different task. So in that way, the browser can do more than one task at a time. Let's say, for example, one of the processes of this browser, Chrome.exe, is used for displaying the web page on the browser window. And let's say that another thread is used for downloading something from the internet. So we know that when we are downloading something, you can also view the page at the same time. So these two things are happening simultaneously. That is possible because we are having multiple threads. One thread taking care of displaying, and the other thread is taking care of downloading. So if we were having only a single credit process, then while the downloading was happening, the page could not be displayed. Or while the page is being displayed, the download will not happen. So that is just a simple example that I want to take in order to make us understand the usage of multi-threaded processes. So different threads perform different tasks, and hence multiple tasks can be performed at the same time, hence improving our efficiency and speed of computation. So we have seen a visual example how multi-threaded processes are there in our system. Now let us see what the benefits of having multi-threaded processes. So from the example that I have taken, you must have already understood the benefits of using multi-threaded processes. But let us understand this benefits in more detail. So the benefits of multi-thread programming can be broken down into 4 major categories. Let's see what they are one by one. So the first benefit is responsiveness. Multi-threading and interactive application may allow a program to continue running even if part of it is blocked or is performing a lengthy operation, thereby increasing responsiveness to the user. So we are having a better responsiveness if we have multi-threading. So I can explain this using the same example that I took about the web browser. Since we said we are having different threads, one for displaying the web page and another one for downloading, and let's say another one for the user to interact with the web page. So if only one thread was there, then until and unless one of the tasks complete, the other task cannot be done. So the user have to wait for one of the tasks to be complete in order to go to the next task. But in case of multi-threading, since different threads are simultaneously performing different tasks, the responsiveness to the user increases. So that is the first benefit of multi-threaded programming. Let us see what is the next benefit. So the next benefit is resource sharing. So by default, threads share the memory and resources of the process to which they belong. The benefits of sharing code and data is that it allows an application to have several different types of activity within the same address space. So the next benefit is resource sharing. So when we saw the diagram of multi-thread processes here, we saw that these multiple threads, they are sharing the resources of the same process. So the code, data, and files are shared between these 3 threads. So we send that it shares with other threads belonging to the same process, its code section, data section, and other operating system resources such as open files and signals. So we see that resource sharing is happening in multi-thread programming. So the benefit of sharing code and data is that it will allow application to have several different types of activity within the same address space. So we can have several different threads in the same address space of the same process. So by resource sharing, we are making our system more efficient because it does not need to have separate or dedicated resources for each and every thread. So sharing resource is another benefit of multi-threaded programming. So coming to the next benefit, we have economy. So allocating memory and resources for process creation is costly because threads share resource of the process to which they belong. It is more economical to create and context switch threads. So we already saw that there is a resource sharing happening in case of multi-threading. So if there was no multi-threading, then we will need to have a separate process for each and every task that has to be performed, and allocating memory and resources for the processes is costly because each process will need to have its dedicated resources and memory, which it may not be able to share with other processes. But in threads, as they are able to share the resource of the processes to which they belong, it is more economical to create and switch between threads because we don't need to have those dedicated resources they are able to share, and hence it is economic. So this economy, it comes from this resource sharing. Now moving on, the next and the last benefit that we have is realization of multiprocessor architectures. The benefit of multi-threading can be greatly increased in a multiprocessor architecture where threads may be running in parallel on different processors. A single threader process can only run on one CPU, no matter how many are available. Multi-threading on a multi-CPU machine increases concurrency. So the next benefit we have is utilization of multiprocessor architecture. So we have already studied about multiprocessor architecture in this lecture series of operating system. So multiprocessor architecture means there are several number of processors in our system. But if we are not having a multi-threaded approach and instead having a single threaded process, then what will happen is that if we are having one process, that one process can run on only one processor or on one CPU. So you may have difference abuse. So let's say, for example, that we are having 4 processors in your system. But even though you are having 4 processors, since your process is a single target process, that single process can run only on one of the processor. So no matter how many number of processors you may have, having a single threader process will run in only one of the processor. But if we are having a multi-threaded approach, then what will happen is that we know that in a multi-threaded approach, each process has different number of threads associated with it. So each of these threads can run on these multiple processors. Let's say that there are 4 threads associated with a single process, and then there are 4 processors in your system. So each of those threads can run on one of the processors. So thread 1 mirror in processor 1, thread 2 mirror in processor 2, and so on. So in this way, we see that the tasks are executed concurrently at the same time, and hence the process will be completed quicker and it is more efficient. That is what we mean by utilization of multiprocessor architecture. So if we don't have a multi-threaded approach, even though we have multiprocessors, it is not very useful because we are not able to make use of the multiprocessor architecture. Or in case of multi-threading, we are able to make use of the multiprocessor architecture, hence improving our efficiency of computing. So these are the main benefits of multi-thread programming. So with this, I hope you got the basic idea of threads and what is the meaning of single thread process and multi-thread process. And we also saw that most of the systems now we follow a multi-threaded approach, and we see that how a single process can have multiple threads associated with it, and how they share the resources of that process to which they belong, and how these things are beneficial for our computing. So we'll be studying more things about threads in the coming lectures. So for now, I hope the basics of thread is clear to you. So thank you for watching, and see you in the next one.